Joy. Hello. Hello. All right. Good morning, you people. Okay. So do you know what's actually really cool? Last year, if you guys ever watch any of the videos from last year that I had a bunch of foreigners in that class. So I had some guy from like Moldova. I had a couple Italians. I had from Ukraine. And I think that was it. Anyway, but still, a lot of interesting. So they would actually do like a good morning for me, for my intro for my videos in some foreign language. Yes, and they would be like, yes, Danke shake. So it was anyway, but okay, infinite limits at infinity, and asymptotes. So I can read the word asymptote, but I cannot spell it for anything. So if I ever have to write it, okay, no, this is the proper spelling of asymptotes, and I'm going to screw it up. So, all right, so investigate limits at infinite limits. As x approaches 0, of the value of 1 over x squared increases without bond. Since the value of 1 over x squared is not approaching to a single number, the limit of f of x as x approaches 0 does not exist. However, the numbers are increasing without bound. We describe this behavior of the function near 0 by saying that it goes to infinity. The limit does not exist. This is super important. Is infinity a number?
No.
No, it's an idea. Infinity is not a number, it is an idea. I cannot put it on a number line. Okay? You cannot count to infinity. Chuck Norris has counted to infinity twice. So, anyway, okay, so now we're just talking about what it's doing. So in these cases that the limit does not exist, it's what is it doing anyway? Okay? So we could say that the limit, instead of saying does not exist, it goes to positive infinity. And then say that f of x is equal to 1 over x squared has a infinite limit as x approaches 0. In other words, a function of f has a infinite limit at c if f is defined everywhere on an open interval containing c except possibly at c. And fx becomes unbounded when x is sufficiently close to c. What does unbounded mean? Say no bounds. Yeah, it goes on to forever, right? Okay, you can't put a cap on it, right? So you're like, no. All right. Investigate the limit at infinity. All right. As x approaches 0 from the right-hand side. So now there's some issues with this. First, what is ln? That's a natural log. That is what it means. It's ln. So a couple things that you guys need to know about it. It's actually going to be log base e. Log base e. Give me 1 second. I have to adjust this. There you go. All right, so back to this. All right, so it's log base e for this value right here. So that's what ln actually stands for. It's a log base e is ln of x. So that's what it means, of x, like that. All right, so for this information right here, ln of 0. ln of 0. These are certain things that I need you guys to try to know off the bat because it's going to make life a whole lot easier. So ln at 0. Yeah.
1.
It's undefined.
What?
ln at 0 is undefined.
Porque.
Porque?
Porque.
Parquet.
Parquet.
Butter. All right, so let's check this out. So right here, we're going to say ln, right? ln at 0. Okay, let's see why. ln of x it does not exist. It does not exist. So certain things with ln that you need to know. ln of 0 is undefined, and ln of 1 is 0. ln of 1 is 0. There we go, right there. ln of 1 is going to be 0. So these are things that, looking at a calculator, you can say, oh, okay, that's why. Let's go back to this. So we know that ln of 0 is undefined. ln of 1 is 0. Okay. These are some things that adding to your notes would be great. It's not specifically on the same concept, but still.
Oh, he was asking.
Yeah. Okay. It is going to be undefined at that point. But now I'm actually going to just look at this at one side. If I'm looking at the limit, I can go back to my graph right here. I get right here. So as it's approaching from the right-hand side, it goes down to negative infinity. Very good. That goes down to negative infinity. So we get limit as x approaches 0 from the right-hand side of ln x is negative infinity. Is it possible to do this from the left-hand side? No. Why? There is no left-hand side, right? There is no left-hand side of this, right? Since there is no left-hand side, I only could do this from the right-hand side. Make sense? Good. All right, so let's go back to here. So investigate. Limit at an infinite limit. So this says we're going to do it at 3 from the right-hand side. Okay. First, on this one right here, can I do it at 3?
No.
Say no. No. No, I cannot. I cannot do it. I cannot do it here or there. I cannot do it anywhere. So is there a removable discontinuity? No, not removable because I can't factor it, right? Not removable discontinuity, so that means I'm going to have an asymptote. Now, I like to cheat on this because, you know, I do. I'm probably a horrible person at this. Anyway, so if it's going to be the right-hand side of 3, give me a number that's close to 3, but on a number line is on the right-hand side. Closer. 3.1. Okay, let's try 3.1. Is that on the right-hand side here? Yeah, that is. So 3.1. So if I were to do that, I know it's going to be an asymptote already. I already do. So mentally, I'm thinking 3.1. So if this is going to be 2 times 3.1 plus 1 over 3.1 minus 3. So what type of number is it going to give me on the bottom? A decimal. Is it positive or negative? What type of number is it going to give me on the top? So it's going to give me a positive, right?
Yeah.
Positive where positive is? So it's going to? Like I said, I like to cheat on this. especially if it's going one-sided and it's going towards some number that is going to be undefined that I can't just plug in. All right, let's see this. So I'm going to do 2x plus 1 over x minus 3. Okay. So now let's look at it again from the right-hand side. So here is 1, 2, 3. Here's 3 right there. Ah, crap. Dang it.
We'll see. What's on the left side?
Menu, window, standard. There we go. All right. So right here at 3, 1, 2, 3, it's going to give me an asymptote here. It's not showing it on my graph. It's going to give me an asymptote. So from the right-hand side, I'm looking at it, right-hand side, it's going up to positive infinity, right? That's how I was able to cheat on that. So mentally, if you look at it and think about it, be like, okay, so if I just put a little bit more than that, then it's going to help me out. The reason why I don't want to use 4 is because 4 is another integer where it might be another number that could be factorable, or there could be something else. Okay, there's quite possibly I know it's on one of my AP test reviews. We did it one year, and we just used the next number, but the next number was also another asymptote, and so but we were trying to find it in between 2, so it's supposed to be in between like 1 and 2. It was supposed to be somewhere in between there, so it was like on the right hand side of 1. And we used 2 instead, but if we used 1.1, it would have been more successful. We would have actually found it. But yeah, we came out with issues on that. So anyway, that's the reason why I say I cheat on this. Okay, so if I plug this in on the left-hand side, if it had said 3 from the left-hand side, what would my answer be? Negative infinity, right? So if I were to do that, I'm just gonna like work this out. So if it's from the left-hand side, let's say limit as x approaches 3 from the left-hand side, from this one up here, so it's going to be a number from the left-hand side would be what? Not negative 2.9, just 2.9, right? Just 2.9. So it's going to be, so it's 2 times 2.9 plus 1 over 2.9 minus 3. So on the top, I end up with a positive number, right? But on the bottom, I end up with a negative number. So therefore, my answer is a negative infinity. That's my little cheat for that one. So yeah. In a way, I am full of cheat.
What if it's negative over negative at the end?
Negative over negative?
Positive.
Yep. There we go. So super easy, right? Okay. All right, so I'm going to clear this up. Let's take a look at the next one. X squared over ln of x of 1 from the left-hand side. So if I'm cheating on this one, I know the left-hand side of 1 would be what? Say 0.9. 0.9. Okay, so I'm going to say 0.9. Angry face. All right, so 0.9 squared over, that's going to be ln of 0.9. Okay, so what did I tell you guys about certain things? ln of 1 is what? 0. That's why I can't plug that one in. ln of 1 gives me 0, so I could not do that. So now, if you guys think about it, so think about what we're talking about and how I showed you a graph of what the ln x looks like, right? Okay, ln x, so in between 0 and 1, where are those values located at on my graph? Those are negative, aren't they? They're below the x-axis. So those are going to be negative values, but at 1, it changes and becomes, it goes positive, right? So to the right-hand side of 1 would be positive. To the left-hand side of 1, it is negative. So I'm going to look at it again. So now right here, I'm going to have a positive over a negative, which gives me negative infinity. X squared over ln x. All right. Tab. There we go. There we go. All right, right there. Up. Control, divide. Trying to go too fast. X squared, right? X squared over ln x. And we get. So from the left-hand side of this function of 1, left-hand side of 1, there's an asymptote at 1, isn't there? So from the left-hand side of 1, this goes down to negative infinity. So using that full of cheat method, did I get that? Yeah. That's easy, right? Okay. So find any vertical asymptotes of the graph right here. Okay. So asymptotes is just like domain. Asymptotes is just like domain. So to figure out what the domain is, I figure out where it cannot be. So what am I not allowed to have here? 0 in the
Denominator.
There we go. I cannot have 0 in the denominator. No 0 in the denominator. So now that means it's going to turn into this. It's going to turn into x over x minus 3, x minus 3. I'm just expanding it. Okay? And now what I'm going to do is I'm going to take the bottom. Always the bottom. Because that's the restriction I have on all of these. There's also another one that actually gives you restrictions, and I'll talk about that in a moment. But I'm going to take the bottom and set that equal to 0. Set it equal to 0. So it's going to be an x minus 3 equals 0. So therefore, I'm going to have what? I'm going to have x. So minus 3 equals 0. So x is 3. So therefore, if this is a domain restriction, I would say that x cannot equal 3.
And then you have to ask them at y equals 3.
Okay.
No.
X equals
X equals 3. That's
x equals 3.
Yeah.
All right. Let's see what it's going to be. X minus 3, right? So tab. X over parentheses x minus 3 close square. There you go. Only have one asymptote there, even though that I have an x minus 3 twice. So still at 3. Properties of limits of infinity. If k is a real number and n is greater than or equal to 2, is an integer, and the function of f and g approaches real numbers as x approaches infinity, then the following properties are true. Okay, so now we're approaching infinity. Actually, do you know what? I'm not going to approach infinity today. I'm going to let you guys get started with this. Monday, I will go back over a little bit. We have a lot of people gone for the thingy. So all these ones that are going to infinity, there's different tricks for this. So I kind of want to, I'll save that one for later. All right, don't forget, like, share, and subscribe. Leave a comment below. I have a PayPal option, donate to, yeah.